Good morning, friends. Today we are going to discuss the next part of this topic. Yesterday we started the heat capacity. We have seen the definition. Heat capacity is nothing but the capacity of the substance in which the quantity of energy required to raise by the 1 degree centigrade or say 1 Kelvin. Two different heat capacities are there, Cp and Cv, that we have seen. Heat capacity at the constant pressure and heat capacity at the constant volume. Then we have seen the some properties of this particular heat capacity. It is denoted by the symbol Q, that already we are. It is denoted by the symbol C. Therefore, the Q is equal to C into delta T, that is the heat capacity. Then specific heat capacity is nothing but the capacity per kilogram of the substance. Heat capacity per kilogram of the substance. It is come for the MCQ purpose. Then molar heat capacity is nothing but the heat capacity per mole of the substance. That you have to remember. Here the two MCQs are there. Then the unit joule per kilogram per Kelvin, and here joule per mole per Kelvin. That units you have to remember, that may come for the MCQs. Unit of the specific heat capacity is dot dot dot. Unit of the molar heat capacity is dot 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 dot. Then heat capacity at the constant volume you can given by the dQV divided by dt. The dQV is nothing but the d by U, that is a change in internal energy, and dt is nothing but d by t, that you can rearrange that you can substitute for this particular dQV and dt. You will get the Cv is equal to d by U by d by t at a constant V. This Cv is related by the equation 3 by 2 R, whereas Cp is nothing but a 5 by 2 R. Then dQp at Cp is equal to dQp divided by dt. You can replace this dQ at a constant pressure, that is nothing but a d by h, that is a change in enthalpy, whereas dt is nothing but d by t. Cp is equal to d by h upon d by t at constant p. Then we have to see the relation between the Cp and the Cv. For that we have to consider the monoatomic ideal gas, which follows the gas law. The enthalpy can be expressed as H is equal to U plus PV, and H is equal to U plus RT. Why? For the ideal monoatomic gas, PV is equal to nRT. For 1 mole of gas, PV is equal to RT. That's why you can substitute, instead of the PV, you can substitute here the RT. This is the equation number 1 and 2. Differentiating equation number 2 with respect to the temperature. Then we have to differentiate this equation. This equation number 2, H is equal to U plus RT. When you differentiate, dH upon dt is equal to du by dt plus R. Cp is equal to dH by dt is nothing but a Cp, du by dt is nothing but a Cv plus R. Therefore, Cp by Cv Cp by Cv therefore Cp minus Cv is equal to R, and after doing this all these things, you will get a Cp minus Cv, Cp by Cv is equal to, for monoatomic gas, Cv is equal to 3 by 2 R and Cp is equal to 5 by 2 R. Cp by Cv is equal to 5 by 2 divided by 3 by 2. That will be Cp by Cv, that ratio will be the 1.667. For polyatomic gas, Cv is greater than 3 by 2 R. Therefore, that Cp by Cv approximately equal to unity. There is one numerical based on this particular topic. Calculate the value of delta H and delta U for the reversible isothermal evaporation of 180 gram of the water vapor at 100 degrees centigrade. Assume that water vapor behaves as ideal gas. Latent heat of evaporation of the water is 539.7 calorie per Kelvin per gram or 2258.1 joule per Kelvin per gram. Delta H is heat absorbed at a constant pressure in evaporating 180 gram of the water. Delta H is given. Delta H is equal to 180 gram of water into latent heat of vaporization. Delta H is equal to, then you have to multiply 180 by the latent heat of vaporization. You will get the delta H. We know that delta H is equal to delta U plus P delta V. From that equation you can calculate the delta U. As we know, for ideal gas PV is equal to nRT. Therefore P delta V is equal to nR delta T. Therefore we can substitute for the P delta V, that there will be the nRT. Delta U is equal to delta H minus nRT. R is 8.314. Number of moles are nothing but a weight divided by the molecular weight of the water. Weight of the water is 180 and molecular weight 18. That is a 10 moles are there. And T is that 100 degrees centigrade. You can convert into Kelvin. 273 plus 100 is the 373 Kelvin. We can substitute it in formula. You will get delta U is equal to delta H is having the value. Then you can put the N. 10 R 8.314. T is 373 Kelvin. After doing all this thing, you will get a delta U is equal to that much joule. Okay, this is about the numerical based on this topic. Then we will talk about the thermochemistry. So the definition will be there for the MCQ. It is the study of heat changes accompanied with the chemical reaction and which are called as the heat of reaction. While writing thermochemical equation, following conventions are followed. Thermochemistry is the study of heat changes accompanied with the chemical reaction and which are called as the heat of reaction also. Then the value of delta H is written after the chemical equation and its SI unit is joule. Temperature in Kelvin is written after delta H. Delta H at 298 Kelvin or delta H at 298 Kelvin, like that. The state of each reaction and the product can be indicated by appropriate lowercase letter abbreviations written after the formula of the substance in chemical reaction equation. Example is given. If the gas is there, then you can mention the G. Liquid is there, L. Solid is there, S. Crystallization is there, the C. Aqueous is there, the AQ. Here the example is given. C graphite plus oxygen gives you the CO2. Here C is in the solid form or say graphite form. Oxygen is in the gaseous form. The product is also in the gaseous form, CO2. Delta H at 298 Kelvin is equal to that minus 398.5 kilojoule. Energy changes are extensive properties which are proportional to stoichiometric numbers in the balanced chemical equation for the reaction. If the stoichiometric number of the chemical equations are multiplied by a factor, then delta H must be multiplied by the same factor. Here 2C graphite plus 2O2 gaseous gives you the twice CO2 gaseous. Delta H is equal to 292. Delta H is 298 Kelvin is equal to minus 398.5 kilojoule. You have to multiply this delta H by the 2 so as to get the enthalpy change for this particular whole reaction. This is about that particular thermochemistry. Thermochemistry is also called as the heat of reaction, that studies the heat changes accompanied with the chemical reaction. That you have to remember. That may come for the MCQ purpose. Okay, please go through this. If you are not getting anything, you can ask it on the WhatsApp group. Okay. Thank you. Here we will stop. Thank you.